Hello, 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 and welcome back. Up to now, we've worked with strings, pointers, arrays, all these different things. And the standard library has some functionality in it, but the standard library does not have everything. And in the last video, I showed how you can work with strings to create the string copy and string compare. Unfortunately, you won't ever need to do that since they're already there. What is not there is something like converting a string to uppercase. So how would you do that? Well, there is a string library that's, if we look at the string library, we have in the strings, we have, not in the string library, but in the, I believe it's the C type, we have checks that can help us along the way. We can check if something is a digit, is graph, is lower, and so on. So we can use the library in here to help us create a function to make our character, to convert our string to uppercase. So for example, there is an upper. So we can check is upper, and there's also a function to upper and to lower. So with that in mind, we can do something like this. C type. Okay, let's go back to include that in there. And we have C type. So we can include and let's say we wanted to convert a string to uppers. So we do something like this. We return the pointer and we call it like this, make upper. Or we can say string to upper. And we pass it the character pointer. So what we want to do in this case is convert whatever we pass to it to uppercase. So what we can do is we can say something like this. As always, we check against no character and we say if my string, and remember it's the pointer, so we have to check the value, and we call the function if is upper. Actually, we want to check to see if it's lower. And we say my string, and we are going to modify the value in my string. And as always, we go ahead and update the pointer, so we say my string and then simply return my string. So let's say that we had a string and we have name as usual 30, and let's just put some random stuff in here, and then we say Joe Smith, and we put a number just so that you can see that the number will not be changed, and we can say string to upper, and we display the name. We have an error. So now it says in line 7, implicit declaration of function is lower. Seems that it didn't like our is lower function, so let's take a look. And I believe it's a casing thing. Yes, it's all lowercase. So if we go back to it, in actuality, this is to upper, and this is lower, all lowercase. And you can see that it converted to upper. So now we can add this to our libraries and keep that, so that way we can convert strings to upper or to lower. And if you were going to do to lower, it's just very simple. You take the same function, so we can say string to lower. But this time we check to see if it's upper, and oh, once again I made the same mistake, and we say to lower, and do the same thing, and now we can actually say the same thing, and this time we go to lower, and we display it, and now we convert it to lower. What if we wanted to have only the first letter uppercase and so on? Well, that's a challenge that I would leave up to you. It is a bit of a challenge, but I'm certain that if you've gotten this far, that you can accomplish that relatively easy. So there it is, to upper and to lower. And notice that I'm doing the same thing, just walking the pointer and converting any string that is in lower. And I think that you don't even have to do this check. It's a safety mechanism, but you don't even have to do it, because I think that to upper already knows that if it's not a lowercase letter, it will not convert it to upper. But just for the sake of safety, we check to see if it's lower, and we make it upper. And here we check if it's upper, and we make it the lower when it is. And why is this important? Well, sometimes you may want to compare strings and you don't care about the case, which brings us to another function where you may want to compare, ignore case. And so you may do something like this and actually take the strings and compare them. But there's a challenge too, though, because you may actually want to do something like, let's say for example we do this, compare no case, and we say care, and we don't want to change the strings, const char s1 const char s2. And one of the first things we have to do is we would have to create an array with the right length. And we haven't gotten into dynamic memory allocation, so I will not touch this one. We can come back to this one. For now, we can do something very brute force, but it won't be correct because you need to know the length of each string. And you cannot dynamically assign the length of each string because you don't know how to do dynamic memory allocation up to this point. So for example, we could just take a very long array, and we could say holder 1, and we could say, for example, 255. Let's assume that we have that. Holder 2, and we have 255. And then we do a simple string copy. Excuse me. And we copy the values from string 1, holder 1, S1. And we do the same thing with this one. And you may be wondering, why am I doing this? Well, keep in mind that these are const characters. We don't want to modify these characters, but at the same time we need to convert them over to uppercase. So instead of converting those, we take our own copies and convert those, and we can say holder 1 and holder 2, and we can convert it to lower. So we can say string to lower, and we pass it holder 1, and we can do the same thing for holder 2, and we simply at this point just return we can simply return at this point the string compare and pass it holder 1 and holder 2. And let's see if this works. Let's say that we compare apple to all uppercase. Let's make it all uppercase versus apple. And you notice it returns 0. Under normal circumstances, it will not return 0 because your string compare, not using this one, if we use string compare, it returns less than 1. So that is one way you can leverage your knowledge of functions to create other functions that will help you accomplish your goals when it comes to string manipulation. And you can use existing stuff to help you modify new stuff. And in this case, we did a very brute force approach by hard coding 255. You could have a string that's 1,000 characters, which this won't handle, but there's ways to do it once you get into dynamic memory allocation. If you enjoyed this video, please share, subscribe, like it, and if you're interested in the code, it will be in the description below. Thanks for watching. Until next time.